Welcome to the Explainer. So, you hit send on a message, and poof, it just appears on the other side. Seems like magic, right? Well, today, we're going to follow one of those tiny messages on what is, no joke, an absolutely epic cross-country adventure.
We're going to pull back the curtain and track a single heroic data packet on its high-speed quest. Our journey starts right here with the laptop in Detroit, Michigan, and our destination? A desktop computer all the way down in Jacksonville, Florida. Let's see how it actually gets there. Okay, so our story begins the very moment you send that message. For our heroic little packet, this is its call to adventure. Before it can go anywhere, though, it has to be created and really prepped for the long road ahead.
First things first, our packet needs a destination. Your laptop does this super fast lookup using something called DNS to find the specific digital street address, the IP address, for that computer down in Jacksonville. I mean, without this, our packet would be totally lost.
Now this is where it gets really interesting. It's all about how the data gets layered up. Just think of it like a knight putting on multiple layers of armor for a dangerous quest. Or maybe sending a letter inside an envelope, which then goes inside a box. Each and every layer has a very specific job. So at the very core, you've got your message. That gets wrapped in a TCP envelope to make sure it arrives safely. Then it gets put into an IP box, which is stamped with both the sending and receiving addresses. And finally, a Wi-Fi frame turns the whole thing into a radio signal ready to be beamed right through the air. Our packet is all suited up and ready to go.
Okay, our packet has been created. And now, it's time to leave home. It's about to cross the threshold from its safe, private home network into the wild, vast world of the public internet.
Your home Wi-Fi router. It acts like a border guard. It can't just let a packet with a private local address wander out onto the public internet. That would be like trying to mail a letter with the blue house on my street as the return address. It just wouldn't work. So the router has a really important job to do.
This whole process is called Network Address Translation, or NAT for short, and it's basically a magic trick that lets billions of private devices, billions, share a much smaller number of public internet addresses. It's a clever and absolutely essential disguise.
So here's exactly what happens. The router swaps the packet's private address for its own public one. It makes a quick little note for itself so that when a reply comes back, it knows exactly which device on the home network to send it to. Now our packet is incognito and ready for the big leagues.
And now for the main event. Our packet gets launched onto the internet backbone, a mind-bogglingly fast network of fiber optic cables. At this point, our data is literally traveling as pulses of light at nearly the speed of light. It's incredible.
You gotta understand, this journey isn't a straight shot at all. Nope. It's a series of incredibly fast hops. From the local ISP in Detroit, it might get zapped over to a huge internet exchange in Chicago, then handed off to another network down in Atlanta, before finally arriving at the local ISP in Jacksonville. And each one of those hops, that's a decision made by a massive router in, like, milliseconds.
Our hero has arrived in Jacksonville. It made it all the way across the country and got to the right ISP. But the journey isn't over yet. Now it has to navigate the local digital streets to find the exact house, the specific desktop computer it's been looking for this whole time.
So once it's inside the local network, the destination router uses a process called ARP to find its final target. It's kind of like shouting out to all the connected devices, "Hey, who has this IP address?" And the target desktop hears the call and replies, "Yo, that's me." And just like that, the router knows exactly where to make the final delivery.
And touchdown! The journey's end is here. Our packet, after its long and perilous quest, has finally arrived at the destination. So now, it's time to take off all those layers of armor and reveal the message that's tucked away inside.
This process happens in the exact reverse order of how it was packed up back in Detroit. The Wi-Fi frame gets removed by the network card. Then the operating system unpacks the IP box to confirm the address. After that, it opens the TCP envelope. And finally, the original, pristine message is handed off to the correct application to be displayed right there on the screen.
Okay, but you might be thinking, how does all this work so flawlessly? I mean, what if something goes wrong? Well, the entire system has this incredible resiliency just built right in. Like if your Wi-Fi signal is weak, it'll just try again. That TCP layer we talked about, it sends little I got it messages, acknowledgements for every single piece. If one gets lost, poof, it's resent automatically. And get this, if a major fiber cable gets cut somewhere, the routers just find a new path. The internet literally heals itself. It's amazing.
But the most amazing part of this entire story is the sheer mind-bending scale of it all.
This incredible, complex, multi-stage quest, it happens billions upon billions of times. Every single second, all over the world. So the next time you hit send, or you fire off an email, or even just load a web page, take a second to appreciate the truly epic, invisible journey your tiny packet of data is about to begin. It really is one of the most incredible, hidden choreographies of our modern world.